Hey y'all, it's me, Miss B. Today we are starting the section on vectors. So we're going to be talking about parts of a vector, multiplying vectors, length of vectors, graphing them, and all that good stuff. Okay, but first we have to know what a vector is. So we'll go ahead and define here. So a vector, PQ, and you'll see that it has a dot here and an arrow here. We call that an array. And this right here, it's just a line on your paper, but you'll have to change it to this like half arrow. And that's read as vector PQ. And we have both the initial side where it starts and the terminal side where the arrow is. And so we can also represent vectors with bold lowercase letters. All right, so vectors are used a lot in engineering and in physics. Okay, so here's component form. Now, component form is a vector in standard position. So, and then also represented by a lowercase letter or the ordered pair terminal point. So with these little carets beside it. And so this right here, as it said, is the terminal point. Okay, a vector in standard position is a vector whose initial point is at the origin. And also, to find component form, you just take the terminal point and subtract the initial point. That gives you a length, and then you just stick it at the origin. So I'm going to go ahead and draw this, vector. So we've got the initial point at 0, 0. And then 7, -5. That's my terminal point. So I'm going to put an arrow on it and draw that line. Okay, so there's my vector. Okay, and that's 7, -5. All right, so here we're going to write a vector. So we're writing vector PQ in standard position using component form. So what that means is I need my vector. So I'm going to take my terminal side minus my initial side. So Q, according to this, is my terminating side. So I'm going to take Q minus P. So it's going to be, so PQ, vector PQ is going to be equal to 7 minus 6 and -2 minus 2. All right, and to simplify, 7 minus 6 is 1, -2 minus 2 is -4. So there's that. All right, we'll go ahead and, do I want to graph that yet? Yeah, let's go ahead and graph it. So we've got 1, -4. Here's our initial side, terminal side. So there is our vector. Okay, if I were to graph 6, 2, I'm going to do that in a different color. 6, 2, and 7, -2. You can see that those two vectors have the same direction and length, and we'll get to that in just a minute. All right, so if V, x1, y1, is x1, y1, then V is equal to x, this isn't right. I'm going to cross that out. It's going to be V is equal to x1j, x1i plus x2j. All right, that's called a linear combination of I and j. where I would be on your x-axis and j is on your y-axis. Okay, so we're going to write this linear combination, which is with that I and that j, and then sketch it. So I'm going to do that in blue. So we're going to have 3, 4, so it's going to be v. Let me thicken this up. V is equal to 3I plus 4j. And I do like to make that I curly, that way I can differentiate it from the number 1. All right, so I guess we'll graph that in blue. So we've got 3, 4. So we graph that. Looks like that. Okay, this one we're not going to sketch on the graph because we're not going to mess with that. But in order to turn it in component form, we take -3, 7. So it's really easy to go back and forth. The hardest thing is knowing those definitions. Okay. Finally, we're on the magnitude of a vector. Okay, so magnitude is the length of a vector, where these symbols, those kind of double absolute value, it's not absolute value, is a symbol for magnitude. Okay, so that's equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So what is that similar to? You should have thought of the distance formula, because that is what it is. And that is what we're measuring. So we're measuring the distance from P to Q, and therefore the length of it, or magnitude. So let's go ahead and do this first one here. I'm gonna move this PQ down so I can write on here. So we're trying to find the magnitude and direction angle. So what I'm going to do is I'm going to take the it's going to be the square root of, we'll call this x1, y1, x2, y2. So we're going to have 4 minus 3 squared plus 2 minus 3 squared. Oh wait, I'm mixing stuff up. Let's start over here. Jeez. I need to have, so x2 is 2, y1 is 3, 2 minus 3 squared, plus 4 minus -1 squared. We'll simplify this the old-fashioned way. So we're going to have the square root of 1 squared plus 5 squared. So the square root of 1 plus 25, or the square root of 26. Now, when I think about this problem, I know that, so we've got 4 squared is 16 and 5 squared is 25. So, and then 6 squared is 36. So I know that somewhere between 5 and 6 is going to be where 26 squared of 26 is. So it's going to be, ends up being about 5.1. And that is units. Okay, and then it does want us to put it in component form. So we're going to say that PQ is equal to our first minus second and first minus second. And so we get -1, 5 for that. So we can graph it. Now, this is so we can get the direction or the angle. So let's go ahead and graph -1, 5. So here is -1, 5. And we'll go ahead and drop that down. And we'll call this alpha, and then this is what am I doing? Okay, we're trying to find theta right here. So I know that this is 1 and this is 5. So then using the distance formula, I also know that this is about 5.1. Not that we need it, but I can say that we'll just call this x. So tangent of x is equal to 5/1. So then using the inverse, x is equal to the inverse tangent of 5/1. Which, when you type that into your calculator, you get that x is equal to 78.7 degrees. And that's giving you this angle here. So if we do 180 minus 78.7, we get 101.3 degrees is equal to theta. Okay, so just to clarify, we've got that the magnitude is PQ is equal to 5.1, and the direction is theta equals 101.3 degrees.